In this segment, we will look at properties and concepts relating to the sine and cosine rules. Let us examine this triangle. How different is this triangle from the triangles we have looked at before? What are your thoughts? I'm reading your thoughts. Are you saying that this is not a right triangle? You are correct. So then, we are required to find the length of the side marked x. Could we use Pythagoras' theorem? What do you think? Is there a ratio that we could use to find the length of this side? Think about it. Actually, you did answer this question before. The trigonometric ratios and Pythagoras' theorem can only be applied in the case of right triangles. In this case, this is not a right triangle. We need another method. Any thoughts? So if you guessed the sine rule, then you are correct. But why will the sine rule work? Why do we use the sine rule given the information that we have here? What are your thoughts? This is the sine rule that ties the sides to the angles. So side A divided by the sine of angle A is equal to side B divided by the sine of angle B is equal to C divided by the sine of angle C. So we'll go ahead and fit this information into the sine rule. Of course, when we use the sine rule, we write it so that we have 3 knowns and we're solving for 1 unknown. That essentially works out to just writing down 2 of the fractions that are part of the formula. Examine this triangle. How does this triangle differ from the previous question that we just completed in terms of determining the rule? Saying that you have noticed that we're given 2 sides and the angle between them, and our task is to find the length of the side opposite to the angle given, then you're onto something. In fact, that is one of the cases in which we can use the cosine rule to answer our questions. Alright, so in this case, the cosine rule will be most appropriate for its use. So let's look at another one. In this case, we're given the lengths of all 3 sides of this triangle. It's a non-right triangle, and we're asked to find the size of an angle. And the angle that we're finding is between 2 of the given sides. Which rule are you thinking? If you said cosine rule, you are correct. Let us see how we can use the cosine rule to help us to solve this problem. Again, the cosine rule is a squared is equal to b squared plus c squared minus 2bc cos a. And of course, a, common A, is the length of our side, and capital A is the size of the angle. And capital A, of course, is the angle which is opposite in location to the side A. In this case, we are given an angle of 115 degrees, and our intention is to find the length of the side which is opposite to that angle, labeled x. We're also given 2 other sides, one measuring 15 units and the other 12 units. In doing this, we first need to identify our A, B, and C. The angle given, we're going to label that as angle A. So angle A is 115 degrees, which means that side A is the side marked X. And of course, sides B and C could vary. We could say let side B be 15 and side C be 12, or vice versa. Let's look at our calculation now. Okay, let's try another one. So here we're focused on angle alpha. The side opposite to angle alpha measures 4 units, and angle alpha has two arms, one having a measurement of 7 units and the other a measurement of 9 units. Okay. Again, why is it that we can use the cosine rule to find the size of this angle? Well, we are given a letter for this angle, which we don't know, but we can find, and the side opposite to that angle measures 4 units. So we do have the angle and the side opposite to it, and we also have two other sides that we can assign as B or C as we so desire. Let's look at our calculation. So we have the angle alpha, which we intend to find. We also have a measure of the side which is opposite to alpha, which measures 4 units, and we have two other sides measuring 7 and 9 units respectively. So let's look at our calculation. So we know that the side opposite to the angle which we intend to find measures 4 units. So plugging this into our formula, we'll have 4 squared is equal to 7 squared plus 9 squared minus 2 multiplied by 7 multiplied by 9 cos alpha in this case. And then we will continue through solving to find the size of angle alpha. So here is a quick recap. When triangles are not right angled, we can no longer use simple trigonometric ratios and must use the cosine and sine rules. Here's a little quiz for you. I'm hoping you'll do great. Go ahead.